Hello everybody and welcome to another session with edupediaworld.com, your favorite portal for online education. Continuing with regression analysis, this session we shall see one of the most important functions of regression, and that is forecasting. We have seen previously that forecasting and estimation are an important use of regression analysis. This session I shall demonstrate by way of taking some numerical problems on how can we do this. Here we go. Well, we have a question here which goes this way. A panel of judges P and Q graded 7 dramatic performances by independently awarding marks as follows. And then we have the data of 7 performers who were graded by 2 judges P and Q, and the marks awarded are given here. The question continues. The 8th performance which Judge Q could not attend was awarded 37 marks by Judge P. If Judge Q had also been present, how many marks would be expected to have been awarded by him to the 8th performance? Well, that is the question, and then it continues. They're asking you to find the other line of regression also. So let's understand the question first. We have 7 performers and they are awarded marks by 2 different judges which are given in this table. Okay, so let's assume that the marks by the Judge P is X and the marks by Judge Q is denoted by Y. So let's assign 2 variables. Let X be the marks by Judge P and Y be the marks by the Judge Q. Okay, now further they say that the performance of the 8th performer was not attended by Judge Q, okay, and the Judge P awarded 37 marks to that performer. Okay, it means that X, the value of X for the 8th person is 37, and then further what would be the marks awarded by Q is what we need to find. Well, that is unknown. Therefore we need to find the value of Y when the value of X equals 37. You need to find the value of Y when X equals 37. So this clearly is here Y is your dependent variable which depends on the value of X. Okay, therefore we need to find the equation of Y equals A plus B X, and once we have got it, we'll substitute the value of X and then obtain the value of Y. Okay, further at the end they have also asked you to find the other line of regression. Just for your practice, you will also have to find X equals C plus dy, but for estimation we'll be using the first equation. Alright, so let's proceed on. Let's find the values of A, B, then further C and D, and then we'll find the values of Y when X equals 37. Okay, so these are the values of different performers. We have the values of X and Y given here. These are the marks by Judge P and these are the marks by Judge Q. Now to find the value of X, we need to or let's use the shortcut method. Let's use U and V. We need to get U and we need to get the value of V. Okay, further we also need to find the values of these U multiplied by V, U square and V square. So let's assume a middle value for X and a middle value for Y. We can take any value here, so let U be equal to say X minus the assumed value of the mean, which is in case of X we call as A, and that could be, let's say, 40. Similarly for Y, let's take a middle value, say 36. Alright, so now let's calculate the values here. We'll have 46 minus 40, and here we will have 40 minus 36. Okay, further let's find the product of u and u multiplied by v. Then we also need u raised to power 2 and v raised to power 2. So u multiplied by v will be this value multiplied by the value here. U square will be the square of 6, which is 36, and finally v square is square of the value here, which is 16. Okay, now I have all the data ready with me. Let me drag this down to the last cell. Yeah, so we have the values here. Now finally let's find the sum of all these, the total value. Okay, that will be given by sum of the values from the first till the last, and then drag this down to the last column. Well, so we have the sum of the values here of u, v, u square, v square, and all these. Next I need to find the averages, the average of x and the average of y. Okay, so the average of x, we can either use the shortcut method or the thing. So let's just do it here quickly. The average would be the value here divided by the number of performers, that is 7. Okay, similarly let's find for the other one. We have the averages now of x and y. Now we are ready to find the values of b, then a. So b will be equal to, if you recall the formula, we have the formula as n multiplied by summation uv minus summation u into summation v divided by n times summation u square minus summation u the whole square. Okay, so my value of n is 7 multiplied by summation uv, which is this value. Okay, minus summation u into summation v, which is this summation u multiplied by summation v, and that's our numerator. That's to be divided by n times n, which is 7, n times summation u square. Summation u square is 91 minus summation u the whole square, summation u raised to power 2. Okay, so that's the thing for b, and we've got the value of b, which is 0.75. Similarly, a would be equal to y bar minus b times x bar. So y bar is 38 minus b times x bar, which is 43. And let me put the second part in the parenthesis. Okay, so that's the thing, and the value of a is coming to be 5.75. Before estimating the value, let's also find the the coefficients which are required for the second regression line. Okay, so those are d and c. So what will be the value of d? D equals, my numerator is the same. The only thing is the denominator will be changing slightly. So let me copy the part from here. Okay, okay, so it's we have n times summation uv minus summation u into summation v divided by n times, this time it's summation v square, summation v square minus summation v the whole square. Okay, so now again d also happens to be 0.75, and then finally c, the value of c will be equal to, x bar minus d times y bar. So x bar minus d times y bar. Okay, so that happens to be 14.5. so that's my value of C. Well, we've got all of these, and what about R? Let's just see if we are getting the same sign or not. R equals to the square root of B multiplied by D, which is this value, multiplied by the value here, which again will be the same because both the values are same. Okay, so here we have got the values of A, B, C, D and R. We are now ready to find the regression equation and then estimate the value. So what will be the regression equation? Our regression equation of the first regression equation will be y equals A was 5.75, okay, plus B was 0.75 times x. Okay, this is your regression equation, and now I need to find the value of y when the value of x is 37. So let's put this value of x equal to 37 in this equation. Okay, in this equation, of course this is again the same equation number 1. So when we put this one, we'll have the value of y equals 5.75 plus 0.75 times 37, and when you calculate this, the value of y would be coming as 33.5 marks. Okay, therefore the marks which judge Q would have awarded to the performance 8, that is the 8th performer, marks expected to be awarded by judge Q to 8th performer equals 33.5. okay, so that's our answer to the first part of the question. And then they're asking you to find the other regression line. We have the data for the other regression line also, and the other regression line, the second regression equation, which is for x, will be equal to C. What was the value of C? C is 14.5, so x will be equal to 14.5 plus 0.75 y. Okay, now here, in case if there was any marks missing for the performer x, we can use, that is by judge P, we could have used this regression equation for that. Okay, so that's the solution of this first question. Let's take another question. Alright, so here we have the other question. The following results were worked out from scores in statistics and mathematics in a certain examination. Okay, you have the mean and the standard deviation of the scores in statistics and score in mathematics given. Further, you are also given the coefficient of correlation, which is equal to 0.42. Okay, and then they're asking you to find both the regression lines. So you need to find both the regression line for y and for x. Then you also need to use these lines to estimate the score in mathematics when the score in statistics is 50, and similarly the score of statistics when the score in mathematics is 30. Well, so the question is long. Let's assume that the score in statistics is denoted by the variable x and score in mathematics is denoted by the variable y. Okay, so now do we need to since this time we do not have a series of data, rather the mean and the standard deviations are given straight away to you. So our work is easy. Let's see how. So this time you have the mean of x. This is x, so this will be the mean of x. This is your x bar, okay, and this is your y bar. Fine. And this is the standard deviation of x, sigma x bar, and this is the standard deviation of y. So you have these values given, and you just and also the value of r. This is equal to rxy, so you have rxy also given. Now this time you'll have to use the relationship between rxy, b and d. Okay, so if you recall, we had the relation between we had rxy equals root under bd, that was 1, but we do not have both b and d here, we just have this one. Further, if you recall, we also have this relation where your b is given by r times sigma y by sigma x, and if you see this formula, you can make use of this to find the value of b. Okay, similarly we also have d equals r times sigma x by sigma y, right? So we will make use of these two relationship to find the values of b and d. Once we have the value of b and d, we also have the averages. We can find the values of a and c, and we'll get all the three equations. So let's do this one. Let's see what will be the value of b. B will be equal to r times, which is 0.42, times sigma y. Now our sigma y is 17.8 divided by 10.8. okay, so when you work this out, you get the value of b equals 0.69. okay, now let's find the value of a. A would be equal to, what's the formula for a? It's y bar minus b times x bar. I have all of these, so the value of a will be y bar, which is here is 47.5 minus the value of b is 0.69 times x bar, which is 39.5. okay, so again when you work this out, you will have the value of a as 20.24. okay, 20.24. Fine. So now we have both a and b. We can write the first equation. Our first equation would be y equals a, which is 20.24 plus 0.69x. okay, so this is the first regression equation. And this could be used to estimate the value of the score in mathematics when the score in statistics is given to us. The same way, let's find the second regression equation, that is the equation of x on y, for which we need the value of d. Value of d equals same 0.42, and this will be just the reciprocal of what we have previously. Therefore value of d will be equal to 0.25. in the same way, the value of c, which is equal to x bar minus d times y bar, and that will be equal to 27.62. well, let's calculate it. Let's put the 10. So c will be equal to x bar, which is 39.5, minus d times, which is 0.25, times y bar, which is 47.5, and when you calculate this, you will get it equal to 27.62. So I can now write the second regression equation, which is x equals c times that is 27.62 times 0.25y. So here I have the second equation, equation number 2. Well, next I need to estimate the values. Yeah, so I've got both the regression equations. Next I need to estimate the values. Use the line to estimate the score in mathematics when the score in statistics is 50. So here what is given is the score in statistics, which is x. Okay, so x equals to 50 is given, and you need to find the value of y. Therefore I'll be using my first regression equation here. So when x equals 50, the value of y would be equal to 20.24 plus 0.69 multiplied by 50. Okay, and when you work this out, it's coming to be 54.74. okay, so that's the marks in statistics when you have the thing. So here the value of y, in this case here the answer is 54.74. okay, and then finally the score of statistics when the score of mathematics is 30, which could be written as score of mathematics denoted by y. So y equals 30. You need to find the value of x, which is unknown. Okay, so for this we'll be using the second regression equation, and that will be your when y equals 30, then x will be equal to 27.62 plus 0.25 multiplied by 30, and when you work this out you will get it equal to 35.12. okay, and that's the answer for this part. So here the answer is 35.12. okay, so we see here that in whatever form the data is given, estimation, which is the last part, is done by first finding the regression equations and then suitably selecting the regression equation depending on which value is given and which needs to be found. Okay, so that way you can always use and you can estimate or forecast the futuristic values, whether it's immediate future or maybe for 2 or 3 years. Fine, so I think by now you must have understood the working, and it's quite simple, I hope, and you need to just consolidate your understanding. So let me give you a question for practice. Here we have the third question for today, and this is a question for you to practice. The question goes this way: obtain the 2 lines of regression from the following data and estimate the blood pressure when age is 50. Well, you have the data of the age of certain number of people and their blood pressure. Okay, you need to estimate the blood pressure of a person whose age is supposed to be 50. Further, the question reads: can we also estimate the blood pressure of a person aged 20 years on the basis of this regression equation? Well, that's something which we need to discuss. If yes, you'll need to find it out. If no, you need to give the reason of that. Well, I leave this question for you to solve, and we shall solve this in the next session together. Till then, keep watching Edupedia World videos. Thank you.